Take a good look at this graph. Here is our graph of y equals the absolute value of x minus 2. It looks like a V, and the point of the V, we call that the vertex, is centered at 2, 0. Now, as I approach 2 from the left, the derivative of this line will be down 1 over 1. In other words, the tangent line here, or the derivative of this line, which will be the slope, will be constant. In this zone here, we have a slope of the tangent line of -1. Over here, our rise over run is +1 over +1. So in this zone here, our slope of the line, which will be the same as the slope of the tangent line, or we could just say the derivative, is going to be +1. So the derivative from the left-hand side does not equal the derivative from the right-hand side. So at this pinch point here, at any kind of sharp point, we say the function is not, wait for it, differentiable. The function is not differentiable. We can't find the derivative right there at that point. Here are some other examples where we have points on our graph where we cannot find the derivative. We say the function is not differentiable at this point. So take a look here at a vertical asymptote. Well, if I'm trying to draw my tangent line here, ultimately I'm going to have a vertical tangent line, and the slope of a vertical line is undefined. So it's the same thing as we come in from the right side of 6. This will be a vertical tangent line. I don't know the slope of a vertical line. It's undefined. So we say that at a vertical asymptote, the function is not differentiable. How about here? The limit from the left will not, I'm sorry, the limit from the left is fine. The derivative, or the slope of the tangent, as we get closer and closer here, look at, from the left side of 3, the slope of that tangent line is getting steeper and steeper negative. As we look at, from the right side of -3, the slope of that tangent line is getting positive and more and more positive as we get closer to -3. So the limit, sorry, I keep on saying the limit. The derivative from the left will not equal the derivative from the right. So at these pinch points here at 3 and -3, we're going to have a function that's non-differentiable. How about here? Look at our M tangent. Our tangent lines are going like that there, and this here. We don't have the same derivative from the left and the right. So at a jump discontinuity, we also say that the function is not differentiable. 2 more cases where our function is not differentiable. Not cases, but examples. Right here, we've got this pinch point. Well, the derivative from the left of -4 does not equal the derivative from the right of -4. So we don't have a derivative at x equals -4. We say the function is not differentiable. Interesting here, if I had y equals the square root of x minus 2, I would get this graph. How about our derivative, or our m tangent, our slope of our tangent, at this point here? Well, is it here? Is that our tangent line? Or is that our tangent line? Or is that our tangent line? It's very hard to tell. So at a point like that, we'd say, I don't know the derivative. I don't know the slope of the tangent line. It's not differentiable.